Hello everyone, welcome back to the good stuff we've been doing. Here we're going to work on we're going to introduce the integral functions. When we integral functions, we mean the sum of algebraic terms where the power of the unknowns are integral are positive. Let's say, for example, you have 3x squared, then you have, let's see, you may even have a y squared, and you have, let's say, 4b squared. No, let's say 4z squared. Then here you see that the power of x here is integral and positive. Likewise the power of y here. So if we add this expression, let's call it p, then it's 3x squared plus, let's say, ay squared plus 4z squared. Now this p is a function of x, y, and z. Here a, 4, and 3 are all constants. They will not change in value. P will depend on x, y, and z. Like the value of p will depend on the value of x, y, and z. A is constant. If x, y, and z are all 0, p is sure to be 0. But then even if a is 0, p may not be 0. P can still be equal to 3x squared plus 4z squared. Here the value of p will still depend on the value of x and z. So in this case now, these variables x, y, and z, because they have integral powers, positive integral powers, we call this p an integral function. So p is an integral function of x, y, and z. Here let's consider an example. If we had, say, x, no, I meant to use a different color pen. So if we had here x over a plus y over b plus z over b, and let's say this expression is equals to a, capital A. So here, if a is regarded as a function of x, y, and z, like that is, if the value of a depends on the value of x, y, and z, here only x, y, and z may change. Like we may have x to be 1, y to be 2, and then z to be, let's say, -1 even. Or we may have x to be 0, y to be 4, and then z to be -5 or so. If it happens that x, y, and z are allowed to change, but that a, b, c are constant, this a is an integral function of the variable x, y, and z. But then what about if we had b is equals to a over x plus b over y, then plus z over, not z. Okay, notice that here I wrote b twice. I should have written just c. Why do I always forget this? So let's say we have z over, not z, but c. Say c over z. So if it happens that b is depending on x, y, and z, so here b cannot be regarded. B is not an integral function of x, y, and z. Why? Because here the powers of the unknown are fractional or negative. Let's say b is same thing as a to the x is -1 power plus b x is y, not x, plus small b y to the -1 power plus z plus c z to the -1 power. So you see that it does not have positive integral values, the powers of the unknowns. So these are actually called rational functions. They are called rational functions. For in the same vein, if we had expressions such as c is equals to a x to the 1 over 3 plus say b x, there may not be x, maybe y to the 2 over 3 and so forth. Such expressions, let's say c z to the -1 over 4. So these are actually rational functions, not integral. The power of the unknowns are rational, and some of them are negative as well. For it to be an integral function, it has to be in the form a, then the ax, it will be probably to the m power, where a may be 0, but it has to be positive or 0, plus bx to the m, something like this, x to the n, plus c, let's say y to the k power. It has to contain positive integral values for it to be an integral function. So even though -2, -3, and -5 are integers, x, if we have a is equals to a to the x is -1 plus bx is -2, we will not regard this as an integral function, because for integral function we don't mean that the power of the unknowns are integers, we just want them to be positive integers only. Now let's look at a more general case for a single variable. Here we see that this is an integral function where if n is allowed to be from n goes from 0 up to infinity, like may not be infinity, it's up to some value, may not be infinite, just that n goes from 0, n is positive, let's put it that n is greater than or equals to 0, and n is an integer. So this condition here, let's for example, we can have a as 5x to the third power minus 3x to the second power plus 2x minus 1. So these two terms are similar, just that here the a sub n, that is, this a sub n means the coefficient of x to the n power is 5, here is n is 3, and the coefficient of x to the n minus 1, which we denote as a sub n minus 1, will be -3. Here this will be 2, and then here a sub 1, no sorry, this is a sub 0, which is the constant is -1. So in this case, this is an integral function but for a single variable. So this is an integral function of a single variable. So for integral function of a single variable, it's always in this form here. So you see that a sub n x to the n plus, like this is the form, general form it could be. It may even be like, you may have b to be x to the 8 minus x to the 5 plus x squared plus 6x. You may have something like this, minus 2. Mean that it does not mean that x to the 7 has to appear. It may mean that the coefficient of x to the 7, which is a sub n minus, like this coefficient of a sub n minus 7 here, it may be that this term here is 0, like small, this term here may be 0, like a sub n may even be 0 for this case now, and x to the 6th power is 0. So even here x to the 4th power, x to the 3rd power are all 0. So it does not mean that it will have to follow uniformly. No, it's really the case even. So, but what we mean is that these terms here can be 0, can be 1, can be negative. They can even be fraction. Like, see, you can have b to be 2 over 3 x to the 4th power minus 1 over 3 x to the 6th power. No, let's say x to the 2nd power also, plus 2 over 5 x. If we may have this case, this is still an integral function, because for it to be an integral function, the variable, the exponent has to be positive and has to be positive and not be a fraction. So this is general introduction to what integral functions are. In the next video, we're going to really work on them and see how we can derive the binomial theorem. Thank you for watching, and please subscribe to the channel. Have a nice day.